Hello, and welcome to the adventures of the Distribution Ninja, Part 1. Now, I need you to watch this video. We're going to learn some properties here, and Distribution Ninja is the setup for the whole year. Crime is rampant in the city. The streets are run by a powerful gang known as the Associates. No one is willing to stick up for innocent citizens. Even poor little old ladies are not safe from the goons and thugs of the Associates. Of course, you know that guy's a thug because it says so on his shirt. And she says, "Help, poor little old lady." And he just says, "Thug life." From this darkness came a mysterious hero, one with powers never seen before. Out of the darkness comes a ninja that fights for the innocent. Distribution Ninja fighting goons and thugs. And of course, what do they steal? Old lady's purse. Car stereo. I guess people still steal those. A bag with a dollar sign. You always see that stolen in cartoons. And of course, yeah, there it is. The homework that you said you did, but it was stolen. The goon did it. The Associates are not happy to hear that their properties, get it, are getting damaged by the new street hero. The Associates, a shady looking group there, get their power because it does not matter which groups you associate together. Their quantities will be the same. This is how no crime has ever been linked to the leaders. Now look at the example below. If you took A plus B, like say these two guys together, added those two first, and we know that it's first because of the parentheses, and then added C, this guy over here is our C, it's the same thing or equal to, and again, this is why this is known as a property of equality, this guy, A, plus these two guys. So no matter if you group these two guys or these two guys, if all you're doing is adding, doesn't matter what order you do them in, and this, of course, makes the crime family more powerful. The Associates. This also works with multiplication. So A times B and then times C is the same thing as B times C and then times A. Okay. Followers, the supply of followers would multiply because of this property, which became known as the associative property. Now, for my students at home who are taking notes, yes, this is where I would like you to write it down. What is the associative property? We have an example of the addition property, the additive associative property right here. Pause if you need to. And you have the multiplicative property of the multiplicative associative property. Okay, so if you need to, write that down. We'll set this up. We'll talk about it tomorrow in class. The Associates never lose followers because that property doesn't work with subtraction. Those that try to subtract sleep with the fishes. Dun, dun, dun. So never use the associative property with subtraction or division. Otherwise, you may be sleeping with the fishes too. The Associates sent out some of their best hitmen out to capture this new hero. First, they sent out the commutatives. The commutatives are a pair of twins that move so fast you can hardly see them. They are interchangeably fast. Plus they're twins, and they both wear sunglasses. The commutatives change position in opponents. Can't tell which twin is which. See the example below. So we were taking notes over there. I think you can figure out where this is going. The commutative property says that if you have A plus B, it's the same thing as B plus A. And if you think of the word commute, part of that commutative, commute would mean move. So they're essentially switching. A and B switch to B plus A. This also applies to multiplication, but just like the associative property, not to subtraction or division, because you end up sleeping with the fishes. Oh, there he is. Creepo. The Associates sent another hitman out for our hero. This villain was able to take the identity of any person he desired. He was a shapeshifter that always fooled a would-be captor. And of course, had very creepy eyes. This villain was known simply as Dr. Identity. He could use his powers like this. Using his magic medallion to multiply anything times 1, and he could change form. So, for example, A times 1, and he retains his identity, or he retains the identity of whoever he wants to look like. And I can see why you'd want to do that when he looks like that. Or he could use his magic medallion to add nothing to his own personality to change form. A plus 0 is equal to A. Both of these properties became known as the identity property. Over here we have the identity property of multiplication, the identity property of addition. Like I said, write these down, add in these properties. Identity property is something you'll need to know. Dr. Identity had 2 more powers, very useful in algebra. He could use his magic medallion to multiply his form by its opposite, or what's called the multiplicative inverse, to get back to 1, or his old self. So A times 1 over A, and of course 1 over A is the reciprocal, or what's called the multiplicative inverse. A times its reciprocal is 1. If you need a number example, think of it like this. 5 times 1 over 5, its reciprocal, would be 5 times 1 is 5, 1 times 5 is 5, and 5 over 5 is 1. We can talk about this tomorrow if I lost you. This property, of course, became known as the multiplicative inverse property. So if you need to pause and write it down, pause now while he's staring at you. In a final act of destruction, he would multiply his enemy by 0, which, of course, we know what happens when you multiply by 0. It's the elimination of his enemy. A times 0, of course, is equal to 0. Dr. Identity called this the multiplicative property of 0. The associates sent out their 2 best hitmen to take out our hero. They were confident this would be enough to destroy their enemy. What will happen to our hero? Will the Distribution Ninja be able to defend the city and fight off the assassins? Find out in the next episode of Distribution Ninja. We'll talk, and I'll see you guys tomorrow.